What's the point of storing data if you can't do anything with it? An analytical tool enables you to take the data you're already investing good money to obtain and generate greater returns on that information. RavenDB, historically an OLTP transactional database, now provides you an OLAP ETL that lets you continuously move your data into a data lake and store it in columnar form so you can create any reports you like using the business intelligence solution of your choice. Being a distributed database, you can take data from thousands of edge points and combine it to learn amazing things about your organization. Things like, how many products did you sell at 12 noon on Tuesday? Is there a correlation between the weather and the number of people entering your store? Are you spending too much in inventory for the month of March? Implementing RavenDB's time series model on an ACID and distributed database gives you the opportunity to achieve unprecedented levels of precision to uncover new opportunities about your business. Today, RavenDB CEO Oren Aney shows you how to move your RavenDB data into a data lake and create reports with dazzling metrics. Feel free to ask questions by clicking the Q&A button at the bottom of your screen, and Oren will be happy to answer them throughout the session. Enjoy our presentation, and here's Oren.
Hi everyone, thank you for joining me for this session. This is an interesting discussion because this is not so much a RavenDB feature. This is a feature that RavenDB has that enables you to do quite interesting things completely outside of RavenDB. So before we get started, as usual, if you have any questions, if you have anything that you would like to comment, please do so in the chat, in the Q&A. I will be very happy to answer you. And let's start with talking about OLAP. OLAP is online analytical processing. This is to distinguish from OLTP, online transaction processing. Now, the major difference between those two is what do you use it for? Typically, RavenDB is used for OLTP, for business applications to manage transactions such as order, invoices, or maybe recording comment on a blog post, or a whole bunch of other stuff like that. OLAP, on the other hand, is typically aimed at, oh, I want to query something. I typically have a lot of data and I want to get some information about that. You may have heard the notion of star schema. There's a whole bunch of ways in which you can organize your information, your facts table, and all of those sort of things in order to get the relevant data that you want. That said, most of the time, this is for analytics, basically reporting. You also see that very commonly used for things like, oh, I need this data to throw that into some machine learning models and stuff like that. This is not something that RavenDB does, or does it? So let's talk about RavenDB and OLAP, or not so much. Let's talk about how RavenDB can help you do reporting. So RavenDB has some features that are specifically there for reporting. For example, MapReduce, which allows you to aggregate over large amount of information. Facets that allow you to slice and dice your data. But the issue here is that both of those are meant for very specific scenarios. Oh, I want to query on orders by customers. I want to know how much money I made from these widgets, those sort of things. RavenDB is perfect for that. It is able to give you on-time, accurate reporting over a vast amount of data. But if you want to explore, if you want to have some data analysts start trolling through the data and discovering all sorts of interesting facts, this is not what RavenDB is for. RavenDB is to store your transactional information. So the standard way of handling that was, oh, let's just use SQL ETL. And SQL ETL will allow me to just push the data out of RavenDB into a reporting database. And that works. So now I can have someone use the standard reporting tools to work with that. Well, we are now in the era of the cloud. So how do I use it again? Now, you can use SQL ETL on the cloud. It would work. But there are two issues with this approach. One, SQL databases in a cloud tend to be quite expensive, especially if you put a lot of data into them. The other thing is that RavenDB is often deployed on the edge, which means that in many cases, you may have many instances that want to push their data for reporting aggregation purposes on a single location, to a single location. This is where OLAP ETL come into place. So let's talk and understand what's going on here. We have some data that we want to report on. Let's say that we have a library and we want to understand how many books were checked in the month of March, or how many works of fictions in the fantasy genre were checked by users, readers, 13 to 18, those sort of things. Now, here we're getting into a lot of tension between the transactional model and the OLAP model. For example, I probably don't care that Jane got a book about chemistry 5 years ago. Not relevant. But I might want to actually still report on that. I don't care that stuff that happened in a transactional database, stuff that happened months and years ago tend to be very cold. You almost never touch it. But with a reporting database, you very frequently need to look up and compare against the past. And again, if we're assuming that we're talking about libraries, we may have many branches. And we want to push the data to many different branches and locations to operate on that. So from many branches to single location, so I can say, oh, I can see that we should get before the catcher in the rye, before the finals, we have to make sure that we have enough copies, something like that. So those are very different scenarios, very different use cases. There is also another issue. If you know that I'm reading about chemistries and, I don't know, flat earth theory, you might be worried that I'm going to put a bomb on the Hubble telescope or something like that. And yes, this is a very intentionally ridiculous statement. So you might find a lot of very interesting details if you're able to track reading habits across large amount of data. And a single branch shouldn't be just have access to, oh, let me just throw the data into some shared location, but let me also be able to pull all of the data out. That is also a very important consideration that we have to take into account. So let's talk about the specific scenario. We have libraries, and we want to be able to do reports across all of them. How do we do that? So now we have these things. And this is some work, some book, apparently it's to die for. And we have those sort of things. So this is a checkout. Let's look at the data. So as you can see here, this is a relatively big database, almost 280 million records. And if I'm looking at here, most of the time I have books. Those are the books for whatever that is. And I have checkouts for that. So this particular book was checked out by this particular user in this time frame. As simple as that. Now, I want to ask questions such as, give me books in particular genre, particular period, or show me books that decline in popularity over time. Show me books that are popular across many years, many decades. What are the classics? Those can be some really interesting details. But if I have many branches, How do I do something like that? How am I able to query across the whole thing? Let's use SQL ETL. And basically, we're saying, okay, give me this, get all of the data out. This is the checkout time. This is the return time, location, the work, the amount that we took, and we hash the user for privacy. Let's call it this way. That would work, right? That's awesome. And now I can run queries. But these actually have several issues. To start with, if I have a lot of checkouts, that means that I'm going to be facing with a very large database in the end. And especially in the cloud, storage space for databases can be extremely expensive. If I'm doing a lot of queries, lots of operations, that means that I have to have bigger instances, not so much. If I have many branches, I have to deal with security. The LA branch shouldn't know what the people in New York are reading, at least not to the point where they can pull all of those details. I mean, if you can say that, oh, there's a lot of chemistry students in Georgia, apparently that might be very concerning because in, I don't know, in London, they only read philosophy books, whatever. So that's a problem. There's also another very big issue here. If we're using SQL ETL, we are generally pushing the data into a relational database. We are generally pushing the data in row forced storage. What does it mean? Rows basically mean just that, rows of data. It looks something like this. Here, rows of data. And that works nicely up to a point. But if I want to do all sorts of interesting queries, a lot of time it's much better for me to store the data in columnar format. Let's say that I want to understand, give me all of the people who read a particular book. I can scan the columns or the rows. So here I'm scanning column by column, trying to find a relevant book. But if I'm using a column-first approach, then I would find the appropriate value, and then I could scan it much, much faster. I'm not going to go into more details with a columnar versus a row format. I'm probably doing a horrible job explaining that. But the whole idea is that there are better formats for storing data for OLAP. And one of them is Parquet. It's compressed, efficient columnar data representation. It's very good. It's standard format, so I can use that in many places and locations. It is a very bad format for writing. Why is that? Because you require batching. The way that it basically works is that we take a whole bunch of records. By the way, this is actually what we'll see now is a Parquet file that we're actually looking at. This is 96,000 records. But the way that it actually works, you can see that a lot of those details are actually represented as columns that are sitting next to one another that can be compressed very efficiently. There's a lot of opportunity. For example, I have here location. All of them are from the same location. So the format would store this once for the entire data. Just as, oh, here is the value repeated 96,761 times. But for something like that, where the values are different, they would be stored in probably some compressed integer format, etc., making them very efficient to scan and operate on as quickly as possible. Now, so the question here is, how does this relate to RavenDB? I mean, I'm giving you Parquet format and OLAP, none of which relates to RavenDB at all. Well, the whole idea is that we made it work. So take a look here. Just to remind you, this is the SQL version, SQL ETL. We are taking the data and we're pushing that into a relational database. What we have here is take the data and push that into an OLAP format. So this operates on checkouts, on these guys. And let's see what it does. It says, give me a value with the location, the work that I'm reading, the number of checkout days, the hashed user, blah, blah, blah. We also have this partition by, which gives me the year and the month. So far, so good. Here is the output of this. You can see how this works. All of the relevant values, and here you can see checkout year, checkout month. Okay, this is confusing. What's going on? Here's the idea. RavenDB is going to use this code, this script that you provided, to generate files, Parquet files. And those Parquet files are just going to store some part of the data, partitioned using the year and the month. So effectively, all of the values for particular month and year would be aggregated and stored inside this file. Okay, that gives me a way to read the data. I guess that's fine, but it's not really that interesting. It gets a lot more interesting when we start thinking, hey, what happens if I push it to the cloud? So this is an interesting idea. And let's see what happens. RavenDB has support for pushing data to a lot of locations. Let's see. What I've done here, I've defined an OLAP ETL process, very similar to the SQL ETL that we have. And here is the relevant script. And you can see that I'm pushing the data with the appropriate partitioning. And we're pushing that to this connection string. If I'm going to this connection string, you can see that right now I'm pushing it into here, and I have some location. You can see that you can push that to many, many locations wherever I want. This is the end result. Here is the checkouts. And now I have quite a lot of data. Here's some Parquet files. Why does this matter? Well, let's see what happens. Now that the data is stored in a cloud storage, we can utilize cloud capabilities to process that. On AWS, this is called Athena. On Azure, this is Data Lake, and you can read, basically. Wherever else, you can use Presto, which is basically what Athena is. And the whole idea is that now the data is sitting on S3. We can make it work. Let's see what happens here. This is running on Athena. And it's this one. And now, there we go. 1 second. So let's look at what we have here. This is the checkout table. We define that this sits on the data in here, in this bucket. It is partitioned by year and month. So let's say that I want to find all of the data for January in 2017. I can go to 2017, and here is all of the data that I need here. So instead of, and the whole idea is quite interesting because instead of having to go through all of this size, which is not that big, I can reduce that to far, far less. Whatever I have in January 1st, which is about, I don't know, 15 megabytes, something like that. So now we know that this is how it's partitioned. We have all of these columns. That's great. I also need to tell Athena, hey, let's do the same for, let's load all of the partitions that you have. And it goes and it scans all of those locations, takes a few seconds, and then we have something that we can actually execute across the entire dataset. Now, the interesting thing about this is that, no, where is that? I had a Parquet file here. Okay, so this is the Parquet file that we're talking about. And I want to notice this is a 2 megabyte file that contain almost 100,000 records. Let's go here for a second. There was, we're now looking, no, I want to get a big one. So let's look at this. This is close to 10 megabyte in size. So this is nearly 500,000 records in 10 megabytes. Now, the reason I emphasize that is that this is going to allow me to query over all of the data and also allow me to split that. So now I want to know, give me the totals of how many people, how many books were checked in a particular month. Let's see how that works. Select quote and count from. Okay. So now I can run this query. As you can imagine, this is going to only look at those values. It scanned 1 megabyte. Now I have my results. Now, as you might have seen, you have the option of running queries that are much more complicated to join, to do all sorts of interesting filtering. I'm not touching on that because this is absolutely unrelated to RavenDB at this point. This is just stuff that you can do on top of pushing the data out. But the key here is that I'm pushing data out from RavenDB, which may again be deployed in many locations, to a single location. I'm now able to say something like, hey, you know what? Let's say that I want to see what are the popular books today. Well, let's see that. In the ETL that I have here, which is currently at about 44% completion, because as you can imagine, that pushed quite a lot of data in. I said, what I want you to do is push that every hour. So it will run until it's over, but then I'm going to be having hourly updates. Could have it every 15 minutes or so, or something like that. But I can have hourly updates to this. And using this approach, I can now get lots of interesting details almost immediately and instantly. The other issues that we are solving here with this approach is that we don't need to have really complex systems. We don't need to have an instance that is able to process data to get ETL from 5,000 libraries branches. we just throw that into S3 or Azure Blob Storage or something like that, and it is now the responsibility of the cloud platform to ensure that they have sufficient capacity. You're only paying for the upload and the storage. Speaking of which, you're also paying a lot less. You're paying a lot less for two reasons. One, cloud storage is cheap, and depending on how available you want it to be, it can be truly cheap. Backblaze is actually cheaper than S3 by almost an order of magnitude, for example. But there is also another factor here. Look, we pushed about 40% of the data. Let's see what the size is. About 2 gigabyte. 2.1 gigabyte. Let's say that when we are done, this would be 10 gigabyte. What's the impact? Well, if I'm looking at the raw data, this guy is 85 gigabyte. Just this single thing here. The disparity in the sizes is huge, especially because now you're not paying for high-end database IO drive, you're paying for low-end just cloud storage. So that is a very good choice to push the data out. Okay. Now, there is something here that we have to take into account. How do we handle updates? How do we handle things that are more interesting? Let's look at the data. I'm pushing the data every hour. But notice what I have here. I'm doing this, and I check that. Let's say I check that today. Yay, checked out. Now wait, and then this is going to be pushed to the cloud. Now I'm going to say, hey, you know what? I'm going to return that. Let's say I return that tomorrow. What's going to happen now? Well, as it turns out, we are never going to delete values. There is no such thing. But we have the ID to help us distinguish things. We have the last modified time to also help us. So let's see. And again, looking into this, you can see the following interesting details. This is the ID of the document. In some cases, either on the same file, not on the same file, but on different files, you may end up with this twice or different times because it is updated. And you can use this approach of saying, take this, give me the latest version that you have, and that will work. Because of this, because we need to support updates, you have to be aware of how this works with regards to the partitioning key. Because the partitioning key should be something that you never changes. Another factor that is also important in terms of the partitioning, again, I'm now touching more on details that are relevant to using Athena or working with big data on its own. But the partition key should be something that you typically filter and query on, because that would reduce the amount of work that you have to do in a significant manner. So let's talk about what are the things that we care about. So first of all, we have the security. You can have an upload-only permissions, so users can only push data and never read it. security, send key only for particular places, stuff like that. Multiple locations can upload at the same time. You don't pay for that capacity provision. This is very, very cheap and can be made cheaper, especially if you know, oh, I'm only going to be typically querying for recent data. So you can use something like intelligent tiering to significantly reduce your costs. Finally, we only upload the data, so you can expire local data. Oh, I don't need to remember checkouts from 1992. The OLAP system does, because I might be interested in discovering what people wanted to read at that time. But the operation system, I can clean all of that information up. I don't care about that. And there are still some details that I want to cover. Let's talk about this. So this is running in batches. Typically, if I'm talking about the SQL ETL that you're probably familiar with, this runs instantly. OLAP ETL run on a schedule. Why is that? OLAP ETL run on a schedule because the whole idea is that we want to gather as much data as possible upfront before we send it to the cloud. Why is that? Because the Parquet format is columnar and would significantly benefit from optimizing across large batches, because we have the opportunity to do a compression, because we have the opportunity to load data in bulk, etc. In a cluster, only a single node, just like other ETL, would be responsible for doing that. The system is optimized for liveliness. What does it mean? It means that we assume that you may have crappy connection. By default, if I'm going to go here, OLAP. You can see here, by default, we're going to send that every 65,000 documents. In this case, I increased that to 8 million, but and the whole idea here is that I want to have larger files here. But that's something that you have to consider. In this case, I'm pushing off the data at once. In most cases, you would be building the data slowly over time. You are unlikely to have 65K on a 65K documents modify every time that you run the OLAP scheduling. And the scheduling is quite important. And as usual, you can think about, oh, how do I handle this? What's going on? Those sort of things. And RavenDB is just going to handle that. It is going to run. If there is a failure, it will retry. It will continue operating. If there is a mishap, it would switch servers. The whole things that you're probably already familiar with. Basically, give me the connection details and move out of the way. I'm going to be dealing with that. Okay. So this is already explained. This is how you get the latest records. And this is actually quite cool if you think about it, because it gives you a lot of opportunities to work with the data. Lots of opportunity to say, oh, let me compare and contrast. Let me see whatever there have been changes, all sort of stuff like that. In general, however, this is where I say I'm not a data scientist. Go find one, give it to them. They will probably love you. A key factor here is that the ETL always work on documents, but the documents doesn't have to be yours. You can have documents that are generated through internal ETL processes that are generated through MapReduce operations. So the whole idea is that you might want to say, oh, let me already do some MapReduce in-house for the thing that I want, and then push the result of that out. And in some cases, this is something that you absolutely have to do. For example, in many medical fields, you're not allowed to push raw data out. You have to do at least some aggregation and some anonymization, or much of other stuff like that. And in some cases, you just don't care about the raw data as is. Just care about, okay, give me your summary and I will sum it across everything. Oh, another thing that I forgot, which is important, a lot of the details here is about, oh, you're going to have many users who are going to be pushing the data. Many, not many users, many locations. You can use it like this. And this is the, oh, this is coming from Ballard. And now I would have that as part of my partitioning scheme. Alternatively, you may want to put it in here to give you some unique value. It all depends on what sort of queries you want to operate on. Okay, this is what I have so far about OLAP ETL. I'm now going to switch to questions that we previously got through the questionnaire. If you have any questions, now is the time to think about them. So we have Panit, who is asking about implementing a BI solution on Encrypted Database. Well, assuming that you're talking about something similar to what I've just shown, this will work on an encrypted database. You have to change nothing, everything is just going to keep working. Conversely, there is also something else that I'm going to, there is something else that I'm going to be presenting at the end of the session. So hold on, and it's also going to be seamlessly integrated with encrypted databases. Chris has asked two very similar questions. Can RavenDB be used for engineering works such as CAD, and an application of RavenDB similar to AutoPlant or SmartPlant? I don't think that Chris is here today, but let's see if I can still answer the question. So when we're talking about CAD, a lot of the question is, what exactly are you talking about? CAD is typically computer-aided design and drawing for houses, or also, well, this is a CAD thingy. If you can see, this is the inverse of Ravenclaw. This is what the actual data looks like. What does that mean? I mean, that creates some sort of an image, presumably. But what do you do with that inside of RavenDB? And the answer is that probably nothing much. This is not data in the conventional sense. I can't ask you, oh, give me all of the drawings that have 3 bathrooms in them. What you typically do in most cases, you would model this as 2 stages. First stage, you would have, call it a project, call it a sketch or whatever. That would be a document, standard JSON document with some descriptive data. Who is the customer? What are they trying to build? Those sort of things. Maybe folklore for approval of building plans. And then inside of RavenDB, let's say that we'll pretend that this makes sense. Inside of RavenDB, you would have something like, here we go. And this is an attachment to store the data. And the idea here is that the attachment would store the data in the format that makes sense for AutoCAD, for SmartPlant, those sort of things. And the document would store the data that I want to do operations on. Oh, give me all of the plans that are under CC Commons that has 2 bedrooms, and 1 bath, something like that. I hope I answered the questions properly. And if not, feel free to ask me that again. I mentioned that I had some more things to talk about BI in general. One of the interesting scenarios that we have is integrating data inside of RavenDB with popular BI platforms. The OLAP ETL that I've shown is obviously one of them. We also have on the roadmap integration with Power BI and with Grafana. We actually already have Grafana integration, but this is for metrics of RavenDB. If you're interested in being able to pull data directly from RavenDB into Grafana dashboards for your data, or being able to run Power BI reports over data that is inside of RavenDB, we have a special surprise ready. I'm really excited to show that, but we want people to give us a look at that, tell us, does it match your scenario, does it not, or what are the things that would get you to use that, those sort of things. We're now in August, we're probably going to be opening that for either September or October. If you have any interest in that, please ping us. My email is in here. And that was everything. If you have any questions, now is the time. In the meantime, I will remind all of you that if you want to use RavenDB, you can go here and start using. This is a public test instance that everyone can use. There is the cloud that gives you a free instance. And we offer a live demo with one of our developer advocates that can walk you through your specific scenarios, show you everything that you can do with RavenDB. And with that, and there'll be no more questions, thank you very much.